If y'all look like y'all ready for 7-4 and 4-8 today. Brianna?
Hmm?
What's that name?
Skylar.
Oh. Hi y'all, so 7-4 goes over quadratic equations, functions, and zeros. All right, so new definition of the day, zeros. And I'll say basically a zero of a function is the solutions of that function, okay? So it's the solution to the function. It's also where the graph crosses the x-axis. And the reason we call them zeros is because when you are solving quadratic equations, you're setting it equal to 0. And remember on the graph, the y values are 0 on that x-axis there, okay? All right, so we got different methods of solving the quadratic equations. All right, so this section, they use 2 methods on that. So the first method we could solve is by factoring. You know, remember to solve by factoring, get everything on one side equal to 0, then you try to factor the polynomial, set those equal to 0, and get them solutions, okay? Second method is a little more work, but it works 100% of the time, and that's quadratic formula. And quadratic formula is the same way. You need everything on one side equal to 0, and then you use your formula. So I'm going to write the actual quadratic formula up here. It's negative b plus or minus square root of b squared minus 4ac. And then all of that is over 2a. And I'll say most of the work, or where I get most of the issues, is in that radical. Now you're trying to separate, simplify the radical down and stuff, is where I usually get the most mistakes in on this. All right, so they'll have a few of each in here, okay? So let's start out on this. They want us to find the zeros of the function. Hang on, for my number one, I got f of s. Oh, I'm gonna make that x up. F of x. S's look like times for y'all. I got an x squared plus 14x plus 45. So no matter which way you go, I'm going to take this function, x squared plus 14x plus 45, and set that equal to 0. And notice, since that's a x squared, I should get 2 answers on that. And either one of them answers, when I plug it back into that, will give me a 0 like I did, okay? So, the first question I look at, can I factor that? So if I was going to factor, here's what I look at when I'm looking at factoring. I look at that last number there, 45. And notice in the middle I got what, a 14? Well, the number in the middle comes from factors of that last number. So are there factors of 45 that I can add together to get 14? 9 and 5 work, right? So since I know this will factor, I'm going to come down and put all this in parentheses, equal to 0. And in factoring, you got to keep up with signs on it. Anytime this last number is positive, both factors will have the same sign as the middle. So I know both of these will be positive, okay? If the last number is negative, then you will have one of each sign in there. All right, what was your numbers? You said 95. So now we've got it factored. So to finish this out, I take both those factors, set them equal to 0, and solve them. So you take each factor. Basically, at this point, once you got it factored, you're just changing signs, basically. So the first one, we subtract 9 from both sides. And I get my first answer, x is -9. And then the same thing on the second one, I'm going to subtract 5 from both sides. And get x is a -5. Okay, so if I wanted to check that, either one of these I can put back in for the x, evaluate that, and I should get a 0 on that, okay? So that brings back factor memories. All right, so I'll do one more where I got a sort of factor, and then I'll get into that quad. Oh, what did I say about that? So now I got an x squared minus 10x plus 21. So that side's positive. So when I factor this, both of these will be negative like that middle number. So is it possible to find factors of 21 that'll add to get me a 10? 3 and 7 work, right? So we're going to break this down into a x minus, and you say what, 3 and 7. You'll notice when you factor, if you add the -3 and -7, you're going to get that -10 exactly. And then when you multiply -3 times -7, you're going to get the 21. So you got to add to get the middle, multiply to get the last. Okay? All right, so the hard part's done. Now I'm just going to set these equal to 0 to get these signs changed. And since both these are negative, my answers will both be positive, right? And then both them numbers, once I plug them in, will give me a 0. Hopefully this is bringing back a few memories. right, so let me do this one. F of x equals x squared. Oh, what I want here, minus 5x minus 36. So I need to give you one with a negative at the end there, okay? So we'll start out by setting that equal to 0. So here's the difference on the first two versus this one. This one has a negative at the end, which means the two factors you find have to have a difference of what's in that middle.
Let's see what equal.
So I want factors of my 36. That when you take those two factors, you subtract to get me a 5. So it's in there. Yeah, there is one in there.
9 and 4.
9 and 4. Right, 9 and 4 is 5. So what you do, you're going to put your x in the x. Because that was negative, I got unlike signs no matter what. Now, she gave me a 9 and a 4. I don't know which one's positive, which one's negative. So here's the trick on that. That middle number is negative, right? Which means my larger factor has to be negative. So that's going to put my 9 being negative, right? And my 4 is positive. But if you add them, 4 and negative 9, give me negative 5. And then when you multiply them, you get the negative 36. So when the last one's negative, you're going to have unlike signs. You're going to find a difference of the factors to equal the middle. And then the larger factor always has the same sign as the middle number. Okay? All right, y'all finish it out by setting these equal to 0 and getting our solutions. So I'm going to subtract 4 from the first one. And then add 9 to the second. Okay. All right, questions online? All right, here we go. F of x equals x squared minus 6x minus 4. So I would look at that and see if I could factor it. But in order for me to factor this one, I need factors of 4 that have a difference of 6. And that's not happening, right? 4 and 1, give me 3, 2 and 2, give me 0. There's no way to get that one solved by factoring. So this one does not factor. So we're forced to use the quadratic formula on this one. So I'm going to get everything set to 0. So the trick on the quad formula is just figuring out what is the A, B, and C that's in my formula. A is the first number here. So since I don't have the number there, it's automatically a 1. B will be the middle number, which is negative 6. And then C will equal the negative 4. So just make sure you got them in the right order, descending order, by them variables. All right, so y'all, here we go. We got x equals negative. You always write the negative that's in that formula. Now, since b is a negative 6, I'm just going to put it in parentheses, I think. But that negative that was in the formula, its only purpose is to change the sign of whatever our b is, okay? So if your b is negative, that negative is going to make it positive. And then we got plus or minus square root b squared will be negative 6 squared minus 4 times a times c. A was 1 and c was a negative 4. And then all this goes over 2 times a, which was 1. So basically, you replace the 2 b's with the negative 6 in the formula, the 2 a's with a 1, the c with a negative 4. Now, we can do a little bit on the outside. Like I can take care of this double negative on the 6, and I can multiply that 2 times 1 on the bottom. But most of my work's going to be up under there. Okay? So, negative 6, I'm going to make that a positive 6. Now, b squared, I don't care what sign you put on that, anything you square better become positive. Right? 2 negatives is a positive, 2 positives is a positive. So let's see, I got my radical, negative 6 times negative 6 is a positive 36. Everything at this right side is getting multiplied together. That's that 4AC stuff, okay? You see 2 negatives there. So that whole side is going to become what? Positive. And then 4 times 1 times 4, what's that give me, like 16? All that's over. 2 times 1 is 2. So y'all, I'm sort of stuck on my outside now because I got to get this radical finished. Well, I can add the 36 and 16. So that's what, 42, 52 all over 2. So we would technically be done if I couldn't do anything else with that radical. But a radical has to be simplified if it can be. So since that's a square root radical, to simplify a square root, you got to pull out any factors of that 52 that are perfect squares. So let me write perfect squares over here. Oh, what's next? 49. So 1 times 1, 2 times 2, 3 times 3. Those are all perfect squares because it's the same number times itself to make that, okay? So 52. Will 52 divide by any of these numbers? Good. And I'd probably stop about 25 because these ones are going to start getting a little too big for it, right? So will 52 divide by 4? See, that's because we're in Arkansas. We put it 12, y'all. 52 will divide by 4.
Yeah, 13.
And give me a 13. So what you would do is take this radical, 6 plus or minus. We said that would be what, 4 and 13? So I'm going to break that into a square root of 4 times the square root of 13 all over my 2.
Okay, where you get the 4 from?
Because it was one of my perfect squares right here, and it divided into 52 and gave me a non-decimal answer. So you want it to divide and give you perfect numbers like that 13 or something without decimals, okay? Well, the reason I pulled that 4 out, can I do anything with that square root of 4? Yeah, what is the square root of 4? So this will now give me 6 plus or minus 2 square root of 13 all over 2. You with me? So that's the main thing you got to look for on those radicals. Now, if it's a prime number, you're not going to be able to do nothing to it, so you just move on. Okay? Like that 13, it's not going any further, is it? Now, y'all notice this. I got three numbers on the outside. All three of them numbers will divide by what? 2. So it's got to be all three of the outside numbers when you do this step, okay? So I'm going to reduce it by dividing everybody by 2. So that means I'm going to get a 3 plus or minus 1 square root of 13 all over 1. So remember, technically there would be a 1 here and a 1 on bottom. But you don't want to write them ones in mathematics because it sort of freaks it out. And it's like, hey, anything divided by 1 is itself type thing going on with it. Okay. So now, if y'all got my program, if y'all got quad program in that calculator. So questions on that? All right, so let's see what we do to this one. This be what, 5? So 4x squared minus the x plus 3. Now, I'm not going to lie, you could try to factor this one, but with that 4 in the front, factoring pretty tricky on this one. I would probably just knock this out with the quad. Get y'all good on that quad, all right? So I'm going to set this equal to 0. I know this time A will be 4, B will be a -1, and then C will be a 3. Then we just plug into the formula and go.
I guess I will find you to memorize that equation.
Oh, this bad thing here?
Yeah, I'm straight out of high school, so my teacher taught it to us.
Yeah, y'all probably did some songs or something.
It's ringing in my head, but the only part I can hear is the 2A.
Yeah, someone told me when they did high school, those fresh, they did pop those weasel type song with it.
Yeah.
So have at it.
The only part I hear.
All over. Anyway.
That's all I'm hearing.
Yeah, what's fun? All right, so here we go. I got x equals -1, so you're gonna have 2 negatives again. Plus or minus square root of b squared, which will be -1 squared, minus 4 times a, which is 4, and c, which is 3, all over 2 times a, which is 4. And then once again, we're going to be under here quite a bit, it looks like. So the double negative makes that a +1. -1 squared would be what, +1? This time, all this is getting multiplied together. There's only one negative, so it's going to stay negative this time. So count how many negatives are on that last part to make that sign either positive or negative, okay? If it's an odd number of negatives, it's going to stay negative. If it's an even number, it's going to become a positive. Then you got to figure out 4 times 4 times 3. So that's what, 48? All over 2 times 4, which is 8. All right, so I can still work under here. So here we go. That's going to give me 1 plus or minus 1 minus 48. That's going to give me what, a negative 47. All over 2. So I'll tell you this. We will take care of that negative that's under that radical. But I need to see if the 47 are divided by any of them numbers. And we're not worried about this one. It don't change nothing. So 47 won't divide by 4. Won't divide by 9. Won't divide by 16. Won't divide by 25. Everything else is getting a little too big for it. So it won't divide by none of those. So the 47 is not coming out of that radical. But we got to get that negative out of there. Now, I don't know if y'all remember, but when I got a radical with a negative under it, I break out that negative as a -1, and then I leave my 47 under the radical. Now, in the real world, we can't take a square root of a -1 because like signs are always positive. But what did y'all replace that square root of -1 with? Oh, damn, that was it, right? So that this becomes an I square root of 47. That's how you get your imaginary numbers from taking those square roots of negative numbers, okay? So now, put that right here, so I get 1 plus or minus I square root of 47 all over 2.
I had 8 turn to a 2. What you do?
What now?
The 8 right there turns into a 2 up there.
Oh, hold on. How did I do that?
Go ahead. That was like, like you got magic powers.
No, leave that at 8. Come on.
Mr. That's on you.
So y'all, if this radical ends negative, you're going to have imaginary zeros. If it stays positive, then you'll have real zeros, okay? All right, this one has x squared plus 3x minus 7 equals 0. All right, so I can't find factors of 7. That'll give me that 3 in the middle. That's only going to give me, what, 7 and 1, give me a 6 or an 8, either way you go. So not happening. So we're going to use the quad again. So we do know A is 1, B is 3, and C is -7. So on the calculator, if you want to use that program I gave you, hit program button. Go down to quad. It's probably about halfway down at this. Oh, you need to hook yours up.
I don't know what it is.
Yeah. And once you enter quad, you enter again and it starts asking you for A, B, and C. Yeah. And just put your A, B, and C like we're pulling them up here. 1 enter, whatever your D is in there, and your C.
I'm having a brain fart.
Uh-huh.
For real.
It's like in the middle.
Yeah.
Yes.
And go down to quad. Enter in. And it'll start asking you for them letters.
This one, but I just put it up.
Mhm. I use this to help me at least see if I'm on the right path. Now, here's the thing about that quad program. It's going to give you decimal answers the first time. We don't want decimal answers. So you hit enter one more time, and it's going to give you the radical answers if you got it.
Oh, mhm.
So, all right, let's see what this one does for us. So negative b, this time b is a positive 3. So the negative basically going to turn that into a negative 3. Then I got square root of 3 squared minus 4 times a, which is 1, c, which is negative 7, all over 2 times 1. All right, so let's see, negative 3. All right, so I got 3 squared, that'll be what? 3 times 3 is 9. And y'all look on the right side, you got 2 negatives, so that's going to become a positive. And then when I got 4 times 1 is 4, 4 times 7, 28. And then all that's over, 2 times 1 is 2. All right, so I can go further still. I got me some adding I can do under the radical. So I got my negative 3 plus or minus, let's see, 928 is, and then all that's over 2. So if we're going to go any further, that 37 would have to simplify. You know, 37 ain't divided by 4, ain't divided by 9, 16, 25, everything else is too big. So since my radical does not simplify, this should be my final answer.
You're not gonna change it like.
Now the calculator gives you 1 plus and 1 minus.
So when you put the I first. How do you put it in the I?
I would only put the I as if my radical was negative under there.
Also, it's enter.
So say at this point I had 9 minus 28, which would have made me what, a negative 19 under the radical. If I had that negative under that radical, then I would have to bring that down as I for imaginary. Okay? So the calculator could have spit that thing out right there just like it looks. Other than we're using shorthand on here with the plus and minus. That plus and minus just means that one time you go through adding it, second time you go through and you subtract it. Okay?
I feel like that just made my whole life easier. That little program just made my whole life so much easier.
And we use that a lot, especially in we start hitting chapter 8 stuff. All right, so let's look at 4A, which is applications of polynomial equations. All right, so let me draw this one here. All righty, y'all. So I got this thing crossing over here at -3, and it's just +5.
Can you put a line on here?
Huh?
It look
Put
like
a line
S.
on here?
That's what it was?
Can you put a
You
line
put your
on
fire
here?
look like S's.
Oh, well, that's why I didn't draw the S one go.
Those are files.
When I say my S's and 5s would be too close, I changed it to an X, remember? All right, so Now this part, I'm just worried mainly about where it's crossing here. So this thing is like a parabola that comes down and goes up. But I'm just mainly worried that it's crossing at -3 and +5. So the equation that models this is f of x equals x squared minus 2x minus 15. So on this problem, they want me to A, find the x-intercepts, and then B, find the solutions. Well, I know the x-intercepts because that's where it's crossing that x-axis at. Now, be careful when you do x-intercepts, they gotta look like points. So what I need to know is what that point is and that point. So since they're x-intercepts, those y values will be 0 for those. So the first intercept will be over here at what, -3, 0. And then what was it? +5, 0. Now make sure you write them as ordered pairs and put them commas where you need them on that. So then they said, hey, what's the solutions? Well, the solutions, I just solved this real quick. So let me see, I got x squared minus 2x minus 15, set it equal to 0. And that one I'm actually going to be able to factor. Because I can find factors of 15 that have a difference of 2. So y'all, we come down with our parentheses. I know I got an x and an x. That thing is negative at the end, so you're going to have opposite signs no matter what. 3 and 5. And the 5 is going to be negative because my middle number is negative. All right, so let's see. 3 and -5 give me -2. You multiply them, you get a -15, okay? So now let's solve them and get our solutions. So set both these equal to 0. So y'all, the first one, I'll subtract 3. Second one, we'll add 5. So I get -3, +5. So what they really wanted you to realize on that is look at these solutions you got and look at these x-intercepts you have. Are the solutions not the same as those x values on those intercepts? Right here I had a -3 for my answer. My first intercept was a -3, 0. Had a +5. Second intercept was 5, 0. Okay, so all solutions will cross the x-axis there. Okay? You're ready for the fun one again. Sure you are, okay. So a wire is stretched from the ground to the top of an antenna tower. So here's my antenna tower. And there's a wire being stretched from the ground to the top of that. The wire is 25 feet long. And then it says, hey, the height of that tower is 5 feet greater than the distance from the tower's base to the end of the wire. So here's the tower's base to the end of the wire. I don't know that distance, so we'll just call that D. But then it said the height of the tower was 5 feet greater than that distance. So that would be what? D plus 5. They want me to find the distance D and the height of this tower. So find the distance D and the height of the tower. tell you what. I'm gonna make this look like a triangle, and I'm gonna draw a little square right there. That means I got a right triangle with a 90-degree angle sitting on it. And y'all should all know a little formula that we use for triangles. How about, I'll say, Pythagorean theorem. Y'all remember that one? All right, what is it? All right, I'm gonna leave y'all on the start. How about this? A squared plus, there you go. Now, the only thing about this is the C squared has to be the hypotenuse, which is the longest side of this triangle. So this has to be the C, that wire. And then A and B can be the other two sides. So let's just plug all stuff into the formula. A squared can be this side, so that'd be what, D squared? B squared will be this side, but that's a D plus 5. So I'm going to put my D plus 5 in parentheses and square it. And that's going to equal to 25 squared, right? So I'll just plug in my sides in. D and squared it. D plus 5 squared it. That's going to equal to 25 squared on that side. All right, so the trouble is going to be that D plus 5 squared. I get a lot of people because they'll put this D squared and then they'll put D squared plus 25. When you see something like that being squared, write it twice in FOIL. So let me get some room right here. So this will equal D squared plus, let's see what we get when we multiply D plus 5 times D plus 5. So y'all, let's see, D times D is a D squared. D times 5 is a 5D. Plus you got a 5 times D in the middle. Plus you got a 5 times 5, which is what, 25. So I'm just going to make it a little smaller by adding those like terms in the middle. So you get a D squared plus 10D plus 25. So what happens when most people shoot them exponents through, they're not getting that 10D they need on that, okay? So here we go. Replace this with D squared plus 10D plus 25. So on the right side, what's 25 times 25? 625. All right, I'm going to add a lot of like terms real quick. I got these D squares that I can add together. So that'd be, oh, you're so close. 2D, 2D. Okay. So that's going to give you 2D squared. So here's one rule on that. When you're adding, you cannot change exponents. Okay. Then I'm going to bring in that 10D. Now, what a 625 is, I need a what? Well, remember, I need to get everything on one side equal to 0. So what we would have to do is subtract 625 from both sides. So that 25 minus 625 is going to give me a negative 600, all equal to 0. Okay. So at that point, y'all got a nice little program y'all can use. That might factor. So what y'all want, quad? So if I'm doing quad, A is 2, B is 10, and C is a negative 600. Now, I'll tell you this. You can even make this one smaller because every one of these is even. So I could have divided a 2 out of everybody if I wanted to. Okay. All right, let's see what we get. Negative b would be a negative 10. B squared would be 10 squared minus 4 times a, which is 2, c, which is a negative 600. Ooh, all over 2 times 2. But we're going to get this number up under that radical, ain't we? All right, y'all, here we go. Negative 10. 10 squared is 100. You got 2 negatives on that side, so it's going to become a positive. Woo, looks like 8 times 6 is 48, so what's that, 4,800? That sound good? All over 4. I think it's 4,800. All right, so now we can add the 100 and the 4,800. That'll give me 4,900 all over 4. I'm going to show y'all a trick. What's the square root of 49? So what's the square root of 4,900 going to be? 70. So you get negative 10 plus or minus, or you can ask that calculator what's square root of 4,900, but it should spit out a 70. All right, so let's see. To get my 2 answers, the first time I take negative 10, add 70, divide by 4. The second time I take negative 10 minus 70, divide by 4. So let's get the first one. Negative 10 plus 70 divided by 4 will be 60 divided by 4. 60 divided by 4, 15. Now the second answer will be negative 10 minus 70 divided by 4. So y'all, that's a negative 80 divided by 4, negative 20. Now, we're dealing with a real world type problem here. One of them answers just does not make sense. I'm measuring distance. Am I going to use negative numbers? No, so anytime you're looking at distance and you get negative numbers, cancel that out. So that my distance D is 15. So if this distance here is 15, how tall is my tower?
20.
20.
20 feet, how tall it is.
Say again?
How tall is 20 stories, 20 feet?
Mm-hmm. Now, if you wanted to check yourself, 25 squared, we said was what, 625? So this is just a check. So you got 625 is going to equal, what's 15 times 15? 225. What? My tower was 20 over here. So what's 20 times 20? 400. Oh, and look at that. 225 plus 400 does equal 625. So when you get on your sides, you should be able to plug it in there and just get it with the Pythagorean theorem just to see if they equal each other, okay? So there's 2 of them kind of problems for you. One trickier than the other.
That's how we got to the end. I forgot we was talking about a tower.
Yeah, you looked at this distance here, and then for that distance of that tower, okay? All right, so we'll finish up some more quadratic stuff next class. So that brings back factoring memories though, right? Quadratic formula memories and all that kind of stuff. All right, y'all, any questions online? All right, online, I need to know who is Shay. I'm not seeing that name on my list. Oh, I couldn't hear you tightly.
I emailed you last night about the internet errors I was having, and I sent you like a picture of it.
So, I'm gonna reset that for you.
Okay, thank you. Because I was like taking it, and I was like kind of doing like the easier ones first. I was trying to get like the ones I could get done as fast as I could.
Okay. Was it the review and the test?
It was just the test because my review, I was doing it, and then like it did the same thing. So then I turned on my computer and turned it back on. It was a whole thing. Then I realized I was like, you know what? I'll just turn on the test right now. So it means all the time. And then it wouldn't let me do anything. I was just kind of stuck there. So then and the time kept going, and it submitted my thing. So
Once the test is open, that thing for some reason it won't.
And I didn't know what to do, and I was like, if I turn it off, like it won't save anything. So I don't know what to do. So
if I'm gonna reset that, then I'll reset both of them for you.
okay, is there any way I could just do the ones I missed, like the ones I didn't finish?
Ooh, I don't know if it'll let us do that. If it was like a homework or a quiz, it would. Let me look on your test and see.
Okay, because I did as much as I could before it turned off.
Right.
And I was like, oh man, like if I.
What was that last name?
Bella.
Okay, Giselle.
Yes.
Okay. All right, so I'll go over there and I'll get that hooked up for you.
Okay, thank you.
All right.
On the test, so one of my solutions, I didn't put the parentheses, I put the correct numbers in there, and it counted it wrong. Is there any way that
Oh,
I
I
can do it? Okay.
Well, and that was
Castellani.
yeah, Thomas.
I don't remember the number, but
Uh,
only one of the two that I missed.
so I'll check that for you too then.
I emailed you my little what we supposed to do that you sent out like bonus or whatever. Did you get it? I like the last one was hard, so I tried.
Oh, I got yours. That was
Because I know I emailed you about the
yeah, I
test
had
and I said
that.
that.
I remember that about the last question.
And then the other one I
You sort of
emailed
like
it to. Yeah. The last one, I just
But usually what I do on those, if y'all doing the bonus, I give y'all the 5 points. So.
I really, because I was like, I don't know what this, and I tried. I sat there and I was like, you're just breaking yourself.
Yeah, so let's see, that was
The X, I don't know. Because like, if it had some numbers, I was like if I could put it in the calculator, I was like, oh, I got it right. When we just like doing like that, I was like, no. And I tried to go back to the ones that had the numbers, like the X and the Y and the Z, and for some reason I just couldn't get it. So that's some stuff that I'm just gonna have to work on. I'm just trying to make sure you have it.
yeah, yours was.
Yeah, like this, like.
Yeah, that's all right. So you got the other one looking good.
I tried to do both of them like you said.
Usually these are for 5 points.
Really?
And if y'all are doing them, I usually give you the 5 points.
Really? Oh Jesus.
Whether they're right or wrong usually.
Oh crazy.
Because y'all are doing the extra work for me and stuff. So
Oh, that's good.
I'll try to get them added on sometime today for y'all.
Okay.
Okay.
Hey, Ms. Rathbone, the lecture you gave today will be on YouTube. Okay, so
I'm about to download this thing now.
Okay, so when I go on there, is there a link to it, or I can just